Okay, let's take a look at section 6.8, the counting principle. First, let's start with example 1. We'll lead into what the counting principle is. It says that you're buying new eyeglasses and must choose the frame, material, and the shape. The frame material can be plastic or metal. The frame shape can be rectangular, oval, cat's eye, or round. How many different frames are possible? So maybe there's an eye store and they're advertising that, oops, let's get our different colors up. Maybe there's an eyeglass store and they have, these are your options. They want to know how many total possibilities are they really offering you? How many different frames are possible? Well, one way to go about doing it is to make a tree diagram. So to do that, we're going to say, okay, we first have to choose the frame material. There's two different frame materials. It can either be plastic or metal. Okay? Now that the frame material has been chosen, then with the frame shape needs to be chosen. The frame shape can be either rectangular, oval, cat's eye, or round. So if you were to go with plastic, you have now these 4 options to choose from here. And I'm going to abbreviate so that we know what they are. RD will be round. Okay, and same would go for metal. You could choose a metal frame with a rectangular shape, an oval shape, a cat's eye shape, or a round shape. So in the end, what this would equal out to be is you could have plastic rectangular, plastic pair that are oval, a plastic pair that are cat's eye, a plastic pair that are round, a metal pair that are rectangular, a metal pair that are oval, a metal pair that are cat's eye, and a metal pair that are round. This ends up being total possible 8 choices. So when they ask us how many different frames are possible, there's 8 different possible choices. Now you might be asking, how does this connect to probability? Well, if we think about what we've been doing, we've been looking at theoretical experimental probability, and let's say we were choosing, what is your probability of choosing the ace of hearts out of a deck of cards? We know that there's 52 cards in a deck of cards, and we can go from there and figure out whatever probability it is we're trying to discover. What if you're an eyeglass shop though, and which maybe you could be, and you want to say, we would want to add to this and say, all right, what's the probability that someone chooses a plastic and round pair of glasses? Okay, so we wouldn't be able to figure this out unless we knew how many total possible choices there were. So what we're doing here is figuring out how many total possible choices there are for things that aren't as straightforward as rolling a die or flipping a coin or a deck of cards, where we already know all of the possible outcomes. Here, we're combining different events, the frames, material, the frame shape, and we have to figure out how many possible choices there are before we go ahead and figure out the probability. Okay, so let's move on down. One way of doing it, like we saw here, is to do these tree diagrams. But what happens if they would have added on to that and said you can also do a red or a pink pair? Well, then you'd have red or pink to branch off of each of these. And that would add to our little list. You have to write even smaller. And then what if they said that you could have a case or not a case? Then you would keep adding. And this could get really big and cumbersome and sloppy. So there's something called the counting principle. And you can read the math lingo here. But really what it says is you figure out how many options there are for your first event, which in our case, we'll just go with what the real problem was saying. For our first event, it was the frame material. There were 2 options. And then we figure out how many options there were for the second event. That was the frame shape. There were 4 options. And if we multiply those 2 together, we get our answer right off the bat. Okay? So let's look at example 2 down here. It says we're going to use the counting principle this time. It says you roll a blue and a red number cube. Use the counting principle to find the number of different outcomes that are possible. Now, let's assume here that what you get on the blue one is, you can't say like, oh, well, the 3 on a blue is the same as the 3 on the red. It doesn't, whatever you get is color specific, okay? So to use our counting principle, we're going to figure out how many options there were for the first event, which is the blue number cube, and there are 6. 1, 2, 3, 4, 5, 6. how many options there are for the red number cube, and there's 6 there. So we're going to multiply 6 times 6, and we get 36 different possibilities. And that's our answer. How many different outcomes are there possible? There's 36 different outcomes. And the reason is, and I'll even use some colors here, if we have a blue cube, we could get a 1, a 2, a 3, a 4, a 5, or a 6. Then we could also, if say we rolled a 1 first on the blue cube, we could roll 1, 2, 3, 4, 5, or 6 on the red cube. Maybe we rolled a 2 first on the blue cube. Then we could roll 1, 2, 3, 4, 5, 6 on the red cube. Maybe we rolled a 3 first on the blue cube. Then you can roll 1, 2, 3, 4, 5, 6, and so on. And you'd end up, when you added all those up, you'd get 36. But it's a lot easier to just say event times event and get your answer. Okay, let's go to the next page. Example 2 you try says, how many different outcomes are possible when you flip a coin and roll a number cube? Okay, so we have 2 different events they're talking about here. The first one is flipping a coin, so we can write that in. And then the second one is rolling a number cube. Alright, so let's figure out how many options we have for both of them. Flipping a coin, there's 2 different possibilities, heads or tails. Rolling a number cube, there's 6 possibilities, 1, 2, 3, 4, 5, 6. So we multiply our possibilities together for a grand total of 12 different outcomes possible. Okay? And we're going to use this then to figure out probabilities in just a little. Example 3, and the last one for this lesson. A combination lock has 40 numbers on its dial. To open the lock, you must turn the dial right to the first number, left to the second number, then right to the third number. Probably like you use in gym class, something like that. You randomly choose 3 numbers on the lock. What is the probability that you choose the correct combination? Okay, so we know we want to find probability of the correct combination. There's only one combination that's going to work. So whenever we go to figure out our probability, it's only going to be 1 out of however many total options there are. Well, that's what we need to figure out, how many total possible outcomes there are. So it tells us that this lock has 40 numbers on its dial. To open it, we need to turn it one way, the other way, then the other way. So there's 3 numbers as part of our combination. So to find our total possible outcomes, we're going to use the counting principle. So let's go to work. Counting principle, we need to figure out our 3 events. That's turn 1, whatever number that would be. Turn 2 is our second event, whatever number that is. And turn 3 is our third event, whatever number that is. So for turn 1, there are 40 options. Turn 2, it never says that numbers can't be repeated, so we still have 40 options. In turn 3, again, 40 options. So we're going to multiply these 3 events together. 4 times 4 is 16, times 4 is 64, and we can add 1, 2, 3 zeros. So that means there's total 64,000 possible outcomes for this lock with 40 different digits on it. So the probability of us choosing the correct combination just randomly is 1 out of 64,000. And if I would turn that into a decimal, we would find that it comes to a very small number. It came out 156.0000156. So that's pretty small. Chances are you're not going to find it, because even if you turn into a percentage, that's not even near even 0.1%, 0.1%. So that's one of the reasons that locks can be so secure. All right, hope all is well, and we'll do some extra problems in class. See me if you have any questions.